So this is the continuation of our Precalc 6-1 notes. And we did not do Gauss-Jordan elimination yet in a video, so that's what we're looking at right now. So Gauss-Jordan elimination is basically taking that Gaussian elimination extra step. And instead of having the matrix with the triangle of ones, but we don't care about the rest of the rows, we're looking at only ones and zeros. So instead of row echelon form, we're looking at reduced row echelon form. So we just are basically solving the system by putting in this form. So that's what we need to do. And the advantage of this is once I get those ones and zeros like this, right away I can tell that in this case my z would equal c, my y would equal b, and my x would equal a. So we don't have to do back substitution. So my first step is always to write as an augmented matrix. So I'm just going through and doing my coefficients and my answers. And then just like before, I want to work from left to right. And so I'm still trying to make sure I want a 1 right here, but these two rows, I want that -1 and the 2 to go away. So what I'm going to do is I'm going to put a star next to the middle row, next to row 2. And in order to get rid of that -1, I'm going to take row 1 and row 2 and add them. And it doesn't matter if I write row 2 plus row 1 or the other way around, as long as I'm writing down what I'm doing. And then I want to go through. In fact, it probably would be easier if I did it the other way, because then I could just copy down what I already have. But that did come up today in my class. Like, do I have to have row 2 first if that's what I'm replacing? And this is just directions for what you're adding, so it doesn't matter. So let's see, when we add, we get 0, 1, 0, 5. So this is really, really nice because what we want is a 0, 1, 0 for that middle row. That's what we have in this row echelon form right here. So that row is going to be completely done already. So it's really nice when that works out. In the third row, I want this 2 to go away. And so now I'm putting a double star there to show where that work is going to be located. And I'm going to get that by doing -2 row 2 plus row 3. So I'm going to double that middle one. So let's go through and do that. That'll give me -2, let's see, -2, 4, -2, 4. Okay. And then my last row, 2, -3, 3, 8. And we'll go ahead and add those together. So let's see what we come up with. So this gives us a 0, a 1, a 1, and a 12. Oh, I guess I got to move my paper a little bit. So my class, I was kind of confused about, like, what do I do with these numbers after I get them? Well, I had 1 star here. This was my 1 star work, and I put that 1 star next to my middle row, and I was trying to get rid of the -1. So when I cancel that, this star was at that row 2. So this is going to be my new row 2. And that was my plan. And then the other one, I put the double star at my last row. So this is supposed to be my new row 3. So now what I need to do is go ahead and rewrite my entire new matrix. So I'm going to do that to the right here. So my first row did not change, but I did change my middle row, my row 2, and I did change my last row. Okay, so we're always working from left to right. My first column is perfect, so I'm not going to do anything with the first column. So now in my second column, I know with this row echelon form that I'm looking for, I want to have a 0, 1, 0. So I need this -1 to go away, and I need this +1 to go away. So I'm going to have to cancel something from row 1 and something from row 3. So I'll put a star here first. So in order to cancel this -1, I'm going to go ahead and take row 1 and add row 2. They're already right next to each other. It seems like that'd be really easy. So let's go ahead and write that out and add them together. Okay. And then I need to do something about this 1 in the middle in my last row. So I'm going to have to use row 2 and row 3. And my reason is even if I hadn't already used, like I already did a row 1, row 2 combination. If I go ahead and put this with row 1, I'm going to end up getting a 1 in my first column position. So in order to get rid of this, I'm not going to be able to use that first row. I'm going to have to only use row 1 and row 2. So I am going to take my row 3 and I'm going to add a negative row 2. And that's so that I could cancel this one out. So my row 3 is 0, 1, 1, 12. And then if I do negative row 2, I have 0, negative 1, 0, negative 5. And when we add together, we get, let me go ahead and move my paper up. We have 0, 0, 1, 7. So now we're always writing our new matrix again. So I'm going to have to, these problems are so big. I think I'm going to move the camera out just a tiny bit. There's always that balance between you being able to read it because it's not too small and then being able to fit everything on there. So this was my new row 1 because it's my 1-star work. I had 1 star in my first row. So my first row is 1, 0, 1, 8. My middle row I did not change. It was already done. And my last row is 0, 0, 1, 7. So my first column is all set. My second column is all set. In my third column, my last row is okay. It's this first row. I need this one to go right here. So I'm going to put a star there. And that means I'm going to have to take row 1 and I'm going to have to add a negative row 3. So if I have a 1 and a negative 1, those will cancel out. And then go ahead and add them. Okay. And now I have the other 2 rows are all set. This is my new row 1. So there's no other work to do. I'm going to write out my final matrix here that's in reduced row echelon form. So 1, 0, 0, 1. Let's see, my middle one is 0, 1, 0, 5, and the last one is 0, 0, 1, 7. So when I have it in this form, it's not like Gaussian elimination where I have to go and do back substitution. I already have all of my variables, so there's no more work to be done. So I know that if my 1x is going to equal 1, my y is going to equal 5, and my z is going to equal 7. And this is just kind of extra, but making sure you understand what we're doing. And so I can go ahead and write that 11157. And we're all set. So the last 2 examples I have for you are kind of some weird stuff that sometimes we run across. So I know when we do systems of equations, when we worked with just systems of 2 equations, you were used to problems where we had many solution or no solution. And we need to see what that looks like now with these new matrix things that we're doing and with the systems of 3 equations instead. So the first thing I'm always going to do is make this into an augmented matrix. And even if I was doing Gaussian elimination, I would still do this. So it's not required for Gaussian elimination according to your book, but we're going to require it. Like we just always need to do this. It makes lives a lot easier. This way I'm not having to write down those letters every single time. So I know the way I always start these is I want to cancel in my first column. I got to work on my first column, and the 1 is okay in my first row. It's these in the second row in that first column position that need to go. So I'll put a star there. So in order to get rid of that 2, I could multiply either of the other rows by -2 and add. So I'm going to do -2 R1 plus R2. So let's see, that means my first row will be -2, -4, -2, -16. And then we'll write down row 2 the way it is. And then we'll go ahead. You know what? I forgot the 1 right there. And then we'll go ahead and add. And so because these are all negative, I'm going to go ahead and just multiply by a -1/3. So I have 0, 1, 3, 3. That's going to be my new row 2. So let me just go ahead and add that note in. This isn't really necessary, but it seems like it's really helping people. So I'm going to now cancel that 1 at the beginning of the last row because we're working on our first column. We always go from left to right. And so I am going to take a negative row 1 and I'm going to add row 3. And that's going to cancel the 1 out. So -1, -2, -1, -8. And my last row is 1, 1, negative 2, 5. Let's see what that gives us. This looks pretty familiar, doesn't it? So this is where we start to think maybe there is something weird going on. So these are the same. That's my new row 3, which means we are well on our way to getting some kind of weird solution. Oh, my work kind of got away from me again there. Back out the camera one more time. So I'm going to go ahead and write my new matrix. So my new matrix, my row 1 has not changed. So I have 1, 2, 1, 8. My middle row is now the 0, 1, 3, 3, and that's also my row 3. So row 2 and row 3 are the same. And because these are the same, I'm not even going to work on canceling anything else right now. By canceling the 2, I'm just going to look with these 2 rows, and I'm just going to see what happens when I get rid of this 1. I know it has to go anyway, and because the rows are the same and I can tell that's where the weirdness is, that's where I want to go ahead and focus. So if I make this one go away, I would have to do row 3 plus negative row 2. And when I add them together, I get all zeros. So I can tell that this is definitely going to be something strange. So what I want us to think about, though, is that because 0 does equal 0, this doesn't mean no solutions. It means I'm going to have many solutions. And so I need to do a little bit more investigating. If I got 0 equals 12 or something, or 15, then I would know it was no solution. I could just stop. But because this is going to be many solutions, I'm going to have to do a little bit more work. And I am going to go ahead and just cancel the 2 in that first row. So that's how I'm making that determination. So my first column is all set. My second column, these 2 numbers were an issue. I got the 1 to go away. Now I'm going to get the 2 to go away. So the way I'm going to do that, I'll put my double star work over here, is I am going to take row 1 and I'm going to add negative 2, row 2. So row 1 is 1, 2, 1, 8. And this one will be 0, negative 2, negative 6, negative 6, and we'll add together. And now I've got my new matrix. So my first row is now 1, 0, negative 5, 3. My middle row is 0, 1, 3, 3. And my last row is 0, 0, 0, 0. So let's go ahead and put this all together. This is as much as we can do on this problem. So since I have nothing down for my last row where z would be, z is just going to equal z. So I'm not going to worry about that. So I'm going to worry about just writing equations right now for row 1 and row 2. So my row 1 equation would be x minus 5z equals 3. My row 2 equation would be y plus 3z equals 3. So because I have z in both of them, I am going to solve for everything in terms of z. So that means for this one that has x, I'm going to add 5z on both sides. So x equals 5z plus 3. And then on this one, I'm going to subtract 3z on both sides. So y equals negative 3z plus 3. And then when I write my triple, I'm just going to make everything in terms of z. So z is going to be the letter z, x is going to be 5z plus 3, and y is going to be negative 3z plus 3. So because I had many solutions, I can't just write many. I need to give some parameters for them. And this says whatever z is, this is how I fix my x, this is how I find my y. So our last problem that we're going to do, it's funny because when I started on this in class on the notes, they said, well, this one's got to be no solution, which is a very good guess, but I'm not going to give that away. And we do want to see how that works out. So here is my augmented matrix. And just like before, I want to work from left to right. I know that this is a 2 instead of a 1, and we can swap rows around, but I'm not worried about it because I wouldn't divide until I got to the end anyway. Like right now I see a 2, 3, the rest of them are all odd. They're not going to divide evenly, so I'm not going to worry about it. I'm just going to concentrate on these 2 rows. So I'm going to put 1 star there, and to get rid of this one, I'm going to do, what do I want to do? I'm going to do row 1 plus negative 2, row 2. So I'm going to use row 1 and 2 for that, even though it's probably not the fastest way. So row 1 is 2, 3, negative 1, 1. And row 2, if I double it, is -2, -2. I'm doubling and multiplying by a -4, -10. And this worked out nicely because I have a 1 here. Oh, my work went off the page again. Sorry about that. So this is when I added them together. So now I want to do something about that bottom row. So now I'm going to use row 2 and 3. So an interesting thing I do want to point out is that I know when I worked with this middle row, you were probably thinking, why not just use row 2 and 3? And I could do that, but I can't do that twice. So I can't do that to get rid of my row 2 and then again to get rid of my row 3. So I'm going to have to involve row 1 at some point anyway. So now I'm going to do negative row 2 plus row 3. So -1, -1, 2, -5, and then the last row, and add them together. Okay, so, gotta get my work back on the page again. So I notice that these start out the same way and they end differently. So this is going to be kind of that weird thing again. So if you think about what this means, the 0 is in the x place, so don't worry about that. But this means if I have 1y plus 3z, it equals -9. But sometimes when I have 1y plus 3z, it equals just 3. So we don't really want that. We don't, like in the last one, we ended up with many solutions because they were exactly the same. So I'm just kind of foreshadowing what we're going to get for our answer. So I'm going to go ahead and fix up my matrix. And then we're going to go ahead and get this finished off. So I am going to go ahead and look to cancel in the last row. We would really want this 1 to go away. So we'll go ahead and do that. So I'm going to do negative row 2 plus row 3. So 0, -1, -3, 9, 0, 1, 3, 3. So just like I said, when I add these together, I get zeros everywhere except on the other side of the equal sign. So this is like saying that 0 is equal to 12, and that is not true. So because we cannot have something like 0 equals 12, just like before, we work with systems, it's no solution. So if we contrast that with what we did in the last problem, here we had a 0 equals 0. And so we had to kind of work through, and we had to give a little bit of guidance to what our x, y, and z needed to look like. We defined everything in terms of z. But in this one, I got something that just wasn't true. So I had to quit, and there's no solution. So this is the end of our 6-1 notes finally.